Another aspect of the implementation that is not quite satisfactory is the way we timed the cooking. When we start cooking in the microwave, we need a timer. Instead, we used a clock which sent us a signal every second. And then when the time left for cooking was 0, we generated a specific event for that within the method. This is not quite reflective of what happens in practice. When we need a timer, we set a timer perhaps on our phone for a certain period, and that will tell us when the timer goes off. We don't look at the clock. So what we are going to have is a timer class. And when we have a timer, there is an object that sets up the timer. So the timer and that object are connected. We set up a timer for a certain duration. And when the timer runs out, a signal has to be generated from the timer and sent to this object. On top of it, we might have a signal that arrives periodically. For example, when I set a timer on my phone, I see the timer ticking every second. It would be nice to have a way to pause the timer and resume it. We might want to change the timing value. For example, we might want to add 10 seconds to the timer. There should be a way to kill the timer in the middle if you don't need that anymore. So those could all be extra stuff that we might want to have in a timer, but we certainly need these 3 things. Well, we were thinking of the clock as an observable, and the timer could actually be observing the clock. But what about the timer and its client? Should they also be using the observer pattern? The advantage of doing that is that it's a well-known paradigm. So if you tell somebody, well, we are using the observer pattern for the timer and a microwave state or whatever, they will immediately know what the design is going to be like. But the drawback is that this may be an overkill for our purpose, because usually when you set up a timer, that is only applicable to the object that wants that timer. A timer is not usually shared by multiple entities. If we take this second approach, which we are going to, this means creating a new user interface so that the same timer can be used by different types of objects. They all have to have this common interface. So we invent a new interface called a notifiable with 2 methods. One is a notification when the timer ticks, and the other one is when the timer runs out. Actually, this should be a void. It is a mistake here. When the timer runs out, there should not be any return value from the method that gets called. So this should be a void. The timer class itself should have this kind of a constructor where the object that creates the timer passes itself. So this is the client, which is the notifiable, as we have seen here. It is told when the timer runs out, when the timer ticks. And this is the initial value of the timer. You could have something like add a time value so that we can add to the timer whatever value we want. For example, we might want to add 60 seconds. User of the microwave presses the cook button, and we can stop the timer. The timer internally keeps track of how much time is left, and who the client is. Then the question is, who should be managing the timer? Should it be the context or the cooking state? Actually, no other entity in the microwave system needs a timer. It is only the cooking state that needs a timer. So why should we delegate this responsibility to anybody else? It is better to keep it local. In fact, if you have the microwave context, keep track of the timer. What if we need multiple timers in the future for whatever purpose? Then the microwave context will have to decide which timer went off and who should be notified, etc. And that makes for very complicated programming. So it is better to have the cooking state, create the timer when it needs, and destroy that timer when it is no longer cooking. Another aspect that is going to be involved in the design of the microwave is how should the display be updated by the state classes? This could be that we have every state send its communication to the display go through the context. This way, if you are changing the environment, for example, if you are replacing the display with some other device, then only the context needs to be changed. On the other hand, if each state communicates independently with a different set of entities, then it is better that we don't go through the context. So it is unclear which approach is better, and we arbitrarily choose that we go through the context to update the display.